Hello, and welcome to part 104, Option Pricing in Greeks. In this video, we're going to go through the answers to questions 10 to 12. You should have a copy of these yourself, these questions. This is just for reference. We're going through put pricing, delta and gamma, and we're also having a look at a put spread. So, first of all, I'm going to find my stock, Apple, using the autocomplete. I'm then going to go to the option calculator. You have seen this before. It's the OVME option calculator. I'm going to use my input data. The underline is 100. It is a put. It is a 90-day to expiry. Now notice, depending on what time of day you're entering this, because Bloomberg measures to the nearest minute expiry times, you will need to add a later expiry time than today of when you're pricing it. So it's a 90-day option, and this time of expiry, 1700, is later than today. So it is going to be a 90-day. The forecasted volatility is 24. The rates are 1%. The dividend yield is 0. For simplicity, the borrow cost is also 0, and that gives me a put price of 4.64, as the option question asks for. Now, you can see that the delta is minus, very important, that minus sign, minus 47%. Those of you who are familiar with deltas in decimals could come to these settings, OVME user settings, and could change them. We wake up on the pricing tab, from scaled to raw, and if you were to do that, press enter on the keyboard and then close the dialog box down, you'll see it becomes minus 0.47, and the gamma indeed is 0.0336. I'm going to put mine back to the defaults, restore defaults. That's probably where most viewers are, which is the scaled Greeks, and then I'm going to close the dialog box. So delta is minus 47.01%. And the gamma is 0.03, as the question says. Now, what would the price of the option be when the underlying moves to 99.9? So here, we're going to have a 10-cent downward move. Because the delta is roughly 50%, I would imagine the option is going to move by roughly 5 cents, 50% of the 10-cent underlying move. But notice the minus sign, which I said to you was very important. If the share price is moving down, the minus delta, a minus of a minus, will make the put go up. So when I enter 99.9 as my new underlying price, and I put my strike back to 100, because the put is still a 100 strike put, indeed I see the price go to 4.69, which is a 5-cent addition to what the put price was before. So that's exactly what I expected. Notice now that the delta has become a bigger absolute number. It's gone from 47.01 to 47.35, i.e. it's starting to move slightly more like a stock than it was before. The movement of the put is getting bigger for the same movement of the share price than it did before. And that's because the gamma was added on to the delta. So the 0.03 gamma was added on to 47 to make it 47.3. Okay, that answered parts 10 part A and 10 part B. Question 11 says, what is the break-even price for this purchase? Well, let me put the 100 underlying price back, and let's go to the scenario tab. Now, straight away, when I turn off the probability density function, and I turn off those expiry profiles prior to expiry, I'll tighten up my range to 85 and 120, where questions B and C refer to those levels. And this is indeed my x-axis price, and it is indeed my profit and loss on the y-axis. I can see that the break-even price has even been read out to me, 95.36, but I can see it here, I can visualize it. Or I can come to the table and I can see that 85, I have a 10.36 profit. At 120, I have a minus 4.64 loss. Just adjust this range again from 85 to 100, and I can see that at 100, the 4.64 loss at 100, and indeed, if I did use the break-even price of 95.36, 95.36, and I go back to that table, you can see at 95.36, 0 profit, 0 loss, the break-even. So that's answered questions A, B, and C. Break-even, which can either be number crunched here in the table, or it could be read off on the graph after the appropriate range of underlying prices are entered, and you see the hockey stick profile. If you wanted to prove that out mathematically, you can see that the strike minus the put premium gets me to my 95.36 break-even. You can see that the distance of the fall to $85, take away the put premium, gets me my 10.36 profit at $85 underlying, and simply the cost of the put will be my P&L, as in a loss of 4.64 at $120. So that's mathematically how I get to those same numbers if you wanted to do it yourself. Okay, that's question 10, question 11. Question 12 talks about a put spread. So we are going to come to leg 1. We're going to duplicate the leg where, yes, this is a put, but this one will be a sell leg. The strike of this one is 95. We're going to confirm that the vol input is still a forecasted vol on the 100 strike. It is a 26 forecasted vol. Notice 2 implied vol points higher for this further out of the money strike. You should be familiar with this on volatility surfaces and skew smiles. It's a very common situation. So the cost of the strategy is the 4.64 you pay for the 100 put, take away the 2.83 you receive on the short put, and this gives you a cost of a strategy of 1.81. That's 12 part A and B answered. Break even of the strategy. Here is how I would get my answers. I would get 4.64 minus 2.83. There's my 1.81 cost of the strategy. What's the answer to how do I get the break even of the strategy? Well, it's the starting level where the stock is 100 minus the cost of the strategy. The break even is 98.19. What's the maximum profit of the strategy? Well, the 100 strike put can work all the way down to the level of 95, and then it stops working because I've sold a put. So in other words, the distance between the puts is $5. So I have $5 working in my favor, but it cost me 181 to put the strategy on. So the maximum profit is 3.19. And at what underlying price does the maximum profit occur? Well, it occurs at that level of $95, where the 100 put has done all it can before the 95 short put kicks in. So the answer to E is $95. Great, thank you, and watch out for further questions.